Academica Media. From Academica Media Studios in Miami, Florida, it's Big Ideas in Education, a weekly recap of inspiration and innovation in your schools.
Welcome to the show, everybody. I'm Ryan Carella. Improving math scores amongst young pupils and treating math anxiety are top-of-mind topics for educators. Are there data-driven insights that we can use to help us address these issues? And what role does emerging knowledge in neuroscience and AI play in all of this? Here to help us address those topics and more is Aditya Nagrath, an acclaimed mathematician and the best-selling author of Treating Mathematics Anxiety, Inclusive Strategies for Working with Students Exhibiting Mathematics Anxiety. Dr. Nagrath, thank you very much for joining us.
Hi, I appreciate you having me. Thank you for having me here today.
I'm excited for this. And though I will admit that the science of math education is not really my area of expertise, I have enjoyed kind of diving into the data a little bit in preparation for this. And in the course of reviewing some of the material here, I was surprised to find out that not only are math struggles still fairly prevalent among young people, but that they start at a very early age. I think I read from one of your documents that 80% of kindergartners have trouble understanding their math teacher.
Yeah, that's what the statistics say. We have a study that we presented. We didn't do the study that said that 4 out of 5 students start kindergarten unprepared for the kindergarten curriculum. And the question was what does that mean? Because we're talking about very young students here. And the answer is that we're talking about a gap in language around the quantities. And the research also shows that children at the preschool level that are doing more mathematics are better reader, writers, and speakers. And that tends to be because, as we found, was that switch to 2-digit numbers, like a 4-year-old will typically go 1-1. So their first encounter where 2 digits are written on a piece of paper and mean something more than the individual characters is right there.
Sure.
And so like when you get to kindergarten, you see CAT. Now that transition's easier to make because you already made it with 11.
Yeah, and I could imagine those struggles are particularly difficult to navigate when it comes to mathematics because everything builds off of everything, right? You need to learn the foundational stuff, to learn the arithmetic, to learn algebra, to learn calculus. And so if you miss a building block along the way, it can be harder to catch up, and because you can't learn the next thing until you learn the previous thing, and it's easy to fall behind. So if we have students sort of playing from behind from the kindergarten grades, it creates a unique challenge for math educators to make sure that they get the skills that they need. Are there any best practices that have come up that kind of help address this foundational gap that seems to be happening at kindergarten?
Yeah, so there's a lot of research that's already out there. A lot of it done just right over here at the University of Denver. I'm in Denver. And they already know kind of the activities that you could be doing with students that are most effective at filling that language gap. They call it conceptual mathematics. So it's sort of the direction the education system started going in, starting around 11, 12, when they switched to the Common Core standards. And I think that the challenge is that there's not uniformity in our education system. You know what I mean? So like, while you can set the standard over here, the way the issue is addressed over here, it's not always uniform. So even if we know, like, hey, here's these activities that help students, it doesn't necessarily mean that people are doing them.
Yeah, implementation, execution, scaling it is a challenge, as it is with any educational endeavor. Now, what role does math anxiety play in all of this? This is a term I've seen come up a lot in the math research, and that having anxiety around mathematics, which many people do, including many adults, can often affect our ability to get the desired learning outcomes we want. How does that fit into the puzzle? And does that sort of anxiety manifest itself in those early years?
Yeah, so like that's sort of the thing, is the anxiety develops because there is that gap in understanding. And so like if also you continue without understanding, then it's like you're supposed to be knowing something. You know what I mean? And so like these things develop at early age, and it was I think a Psychology Today article that says almost half of first and second graders already report having mathematics anxiety, but it's following the same statistics of around that many people are also kind of behind in mathematics.
So what do we do about that in the sense of, is math anxiety a separate symptom that we have to specifically treat on its own? Or is it one of those things where if we focus on the content knowledge and help boost students' mathematics skills, the anxiety dissipates on its own? Like, how do we tackle those two things together?
Yeah, so both need to be tackled, because like if the anxiety is exhibiting in like, I'm not going to hear you type stuff, which sometimes it does, many times it does, then you do kind of have to work with the anxiety. But in our book, we talk about a lot of different tools that teachers could be using to help address the mathematics anxiety. And then a lot of it does kind of involve starting at the student's level of understanding and then building them from there so that they believe that they also can do it.
Now, what role does inclusiveness play in all this? I've heard that word inclusion come up a lot recently in the science of math and math education. What does it mean for math instruction to be more inclusive?
Yeah, well, our strategies were inclusive in the sense that like it includes everybody.
Sure.
So I don't know exactly how to answer the question from other people's perspective, but from our perspective, that's what we meant.
Well, I mean, that's makes a lot of sense, and I think reaching out to different populations is, I would imagine, key to addressing some of those anxiety concerns. I know you've looked a lot into the role that neuroscience can play in addressing some of these math education gaps. Is there anything in the neuroscience of learning that might be instructive for us in terms of effective math teaching?
Well, so like, I don't know about the neuroscience of it per se, but like the activities that the researchers had found to be effective are the activities that are like, if you're interacting with your student, many times you could be reproducing them. You know what I mean? So like for parents, and I know this is for educators, when they go to the grocery store, they say, give me 5 bananas, go get me 4 more. How many bananas do I have? That's one of the activities in our system for teaching addition. That's one of the activities that the researchers recommend that you're doing with the student. But at the end of the day, we're teaching them the language of addition, right? So there's the difference really between mathematics and these other subjects, because we say, hey, well, math, it builds on top of itself. But yeah, but so does the rest of the world, right? So when I talk about a government, right, like you can't just talk to a first grader about government. It's not a base idea. So like, but like at the same time, the problem is that mathematics has that calculation piece. And that calculation piece, I think, maybe triggers this math anxiety that we're talking about. And so now the logic around it starts to dissipate. But like, if the idea is first that the student understands the addition, like what is it? Then that calculation piece comes along because the student sees the usefulness of being able to execute those calculations in a timely manner. And so like, I think that, like, I don't know. Like,
no, that was an excellent.
This is sort of like, yeah.
No, that's an excellent answer, and I think it does point out what I think is a unique challenge that we have when teaching math. Is it's one thing for a student conceptually to understand that 3 + 2 = 5, but it's a separate pedagogical leap, and often a very challenging one, to be able to translate that into the real world setting that you brought up of, if I'm at the grocery store and I have 3 bananas, how many more bananas do I have to buy to get to 5 bananas?
Right.
And, the moment that it becomes real, that it becomes practical, now you're starting to bring language into it and words into it. And it's not just, 2 numbers and a plus sign on a piece of paper. That's an interesting pedagogical challenge, but it also is a learning opportunity, right? Because if you can find a way to make students understand that, if it gives relevance to the lesson planning, it can, sort of, I think,
Well, it's the
activate the
underlying
knowledge in them.
meaning behind the written mathematics. You see what I mean? So like the written mathematics, 3 plus 2, we're doing that in abstract, but in the real world, we do that with concrete things, right?
Yeah.
Like I bought 3 pens and then I bought 2 more and I have 5 pens now. But like, if there's not an understanding of that concrete nature underneath the written mathematics, the question becomes, why am I doing this?
So
You see what I mean?
I mean, if those words matter, right? Like moving beyond the abstract concepts, do you find that as you get into like the later, grades 2, 3, 4, 5, you start to encounter like a new gap that you have to overcome, where if the student has deficiencies in literacy, or, processing of words and things like that, that can affect their ability to grasp those higher level math concepts because the words start to matter then?
Well, so like it's not until I think algebra that you would have that challenge, because when you look at what the mathematics curriculum is going from first grade up to algebra, we're kind of introducing the operations one at a time. We're trying to get some proficiency and fluency around executing the calculations. And we're trying to then introduce a new concept, which is fractions. Again, has a concrete meaning underneath it. And now like you get to algebra and you start trying to abstract it a little bit more. And now after that, a lot of the concepts do become explained in words, but it's very, very concrete until you start to abstract it at algebra.
Yeah. And I noticed that, when I was, in my teaching days, that was always like a big hurdle to overcome, right? I would always come across students in those younger years who were very strong math students and understood, the abstract concepts of addition and subtraction, arithmetic. Maybe even can do some like basic pre-algebra if it was just on paper, x plus 5 equals 6. But the moment that the words came into it, and those sort of practical questions, having to answer word problems, now you're bringing in other content areas that maybe the student might have some difficulty with, particularly if they have some gaps in literacy. And that's just a whole other challenge for math teachers to have to bridge that gap.
Yeah, I mean, so like I see what you're saying, but like the idea is that like the word problems themselves, and it could be that there's a literacy gap, but like at the same time, yeah, I mean, the question is, could they treat the words like a variable? You know what I mean? Yeah. But the way the standards are defining the understanding of multiplication is that you're able to see one of these problems in the world and then say, here's the numbers that I multiply. And so like, that's like the application of the word. That's the application of the idea. And then after that is, can I write down those two numbers as, n times m equals, and then figure out what it equals. And so like, I think that like the challenge is that if you don't have this piece where you can look at the world and see that, right? Mm-hmm. One, you memorize the multiplication tables, you're very good at it, and you're convincing people I should be moving on, right? But you don't understand the ideas. It's a very dangerous situation. And now here's the problem. You get to algebra and you see 7 times x. And like, you didn't have an understanding of multiplication, and now you're throwing another abstract topic such as variables into this situation. And it's like, yeah, I don't get it, right? Like, I don't understand why, like, there's a letter here. I don't understand, like, how am I supposed to use the multiplication tables to figure out this thing, right? And then at that point, we start teaching them technique, which it's okay, right? But like, if they understood that this is like, well, what number times 7 gives you 56, then they understand why you're dividing 7 from both sides, and they understand, like, hopefully understand why, equal means like, hey, you can't just change things willy-nilly because you want the two things to continue to be equal. And then the real question that, people have after that is, why am I doing any of this?
I mean, you hit the nail on the head there with a pretty interesting phenomenon, right? As students in the younger grades go through math instruction, the temptation is so strong for teacher and pupil alike to learn like the rote memorization tricks in math, right? The little arithmetic tricks of like, carrying the one before you really know what carrying the one actually conceptually means, or adding the opposite when subtracting a negative number without understanding why adding the opposite works in terms of subtracting negative numbers. And you can get pretty far into your math instruction learning the tricks, which are valuable because sometimes you need to do something quickly. But if you're not learning the how of the tricks, which I think you would probably agree is the more challenging pedagogical endeavor, eventually that's going to catch up with you when you hit algebra and you have to understand some of those hows to be able to get through that instruction.
Yeah, now you're totally nailing it. And then like the real challenge is that like these underlying ideas, this understanding this that we're talking about, it's hard at this level to call it a pedagogical activity because like really what it is the student has to have an experience and then they have to associate the experience, the right idea behind the experience with the word, right? So so taking it all the way back now to like a 3-year-old, because like it just keeps going, it's the same thing. But at the 3-year-old level, it's a lot like teaching the colors, right? That it's not exactly an abstract idea because I can hold red things, I can hold green things, but they have to understand that the idea that I'm talking about when I'm talking about red is the color, right? So so it takes a little bit of practicing that or having that experience and trying to associate it to the word red. You see what I mean? Yeah. And in the same way, the quantities are there, right? So like you have to have 3 things to say this is 3 things for them to then understand that you're talking about the quantity. It's a little bit more abstract. And then as you keep going with the addition, subtraction, multiplication, right? Like these are kind of more abstract ideas building on top of the abstract ideas. So like, it's not like they can't catch up very quickly. They have more experiences in life.
Yeah.
And those experiences are there. And now you're able to give a word to it. So like what we see in our system is students catch up very, very quickly. Like we've had students that are 12 years old that are testing at the 3rd grade level, both in school and our system, that are able to catch up to age within 6 months because, we're showing them that experience and then we're trying to put words to it. And so then now they say, oh, okay, now I understand now I understand why I memorized the multiplication tables and what it means. And so like, it just accelerates. They're able to catch up and now understand the teaching in the classroom. That was the goal when we started.
And so that's getting back to this idea of relevance, right? Like using the world around them as the setting to teach these things can actually be a catalyst to helping the students get caught up by, showing them that math is everywhere and allowing them to use those real world experiences of being in the grocery store to help them get caught up.
Yeah. And I mean, it's kind of the person having the experience, right? So every single student has to have that, give me 5, give me 4 more, how many do I have now, kind of experience for them to get it. Because it's like when you go to a new job and they say, here's the manual, but like until you log into the software and actually do it, you know what I mean? It's like, yeah, you didn't really get it.
I want to move the conversation to AI and fully admitting that like we're not nearly going to give this topic the time it deserves with the time we have left. But I think I would be doing my viewers and listeners a disservice if I didn't get your perspective on this, because obviously AI is here to stay in education and everything that comes with that, the things that we might perceive as positives and things we might perceive as negatives. But I'm interested in your thoughts on how or what roles AI could potentially play in supporting math educators in the classroom. Have you seen any pretty cool use cases that you'd want to share?
Yeah, absolutely. So like, first of all, thank you for asking me about this. I do got a PhD in computer science and no one asks me about AI. They're like, wait, you're the math guy. It's a PhD in mathematics and computer science. And so like, I kind of have some ideas about this, and I've been given a lot of thought specifically to AI, maybe not necessarily around education, but just more abstractly, right? Mm-hmm. And the real challenge that human beings are facing with AI, I think, are twofold. And I might not remember both fold by the end. So if I forget one, please remind me. But the
Well,
first,
if
the
you give
first
us one
problem-
really good one fold, we'll take that too. But
I hear you. The first problem that people have is that, like, if you're not experienced, the AI is not useful for you, because like the AI, based on like whatever you're telling it, like it can be accurate. It could be, I've seen 95, 99% accuracy at times, but it makes mistakes. And like the challenge is that like it's the experienced person that sees the mistakes. So like I still write software. I'm using the AI to write the software. I see that. And at the same time, we're now implementing AI within Elephant Learning, and we're trying to see how accurate is it at replying to customer inquiries. And what we're finding is that the new people in our system, the new customer success agents, they don't know when the answer is wrong. So like they don't know to correct the AI. But for the person who's been there for a year and they know the answer is wrong, this is an incredible tool, because I could just copy paste this, delete the wrong information, type in the right information, and hit send. Because other than that, it's a pretty close to perfect email. And so like from an education perspective, I think what this means is that we as educators now have to give students more experiences, like more relevant experiences somehow, right? And it involves teaching them everything that we've taught them, because those were experiences that these human beings had before they got there, right? But then like, and I think this probably affects the collegiate level more than, the grades we're talking about. The second issue that people tend to have with AI is the existential issue. Is this thing going to take my job? And like, probably like some jobs are definitely going away. Like that's not a question, right? But like that again places more emphasis in the education system, because now that means we have to educate more people to the level that I'm talking about, where it's like, well, the AI couldn't be doing this by itself. So that's kind of what I'm seeing, right? Is like with the software, it doesn't know what to build. I have to tell it what to build.
Sure.
It doesn't know if it did it wrong. It really thinks it's right. It's just like a human being, by the way. It's like, right? Like I'm like, whoa, this is extremely slow. I've seen things operate way faster than this. Could you like? And then sometimes I even have to go look at the code and say, yeah, no, you totally put a network call in a for loop that like you don't do that, bro, because like you're gonna slow down my for loop. Just do one call.
I do wish I had AI's confidence.
Yeah, exactly. Well,
I wish I could be as confident when I am right as AI is confident when it is wrong about something.
I know what you mean, because like that is probably what's the most dangerous part about it. Because like if you read it and you're like, well, it certainly looks like it knows what it's talking about. But then like AI inside of education, that's a whole nother realm. And I think that like we actually have tools that we're coming in with that I think are extremely useful. What I did with this tool was they were complaining about my son's handwriting. So I told it like, hey, my kid's in 4th grade and blah, 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 blah. And it built a tool for me is what it ended up doing. And this only took 5 or 10 minutes, where I take a picture. The AI looks at the picture and it creates a record for this. It actually goes ahead and grades it for me and tells me whether the kid should redo it. And so now it's not Papa telling him, hey, I need you to write this again. It's GPT telling him, I need you to write this again. And
you don't have to be the bad guy. Be like, look, I think your writing's great, but the AI just...
But also imagine how much easier a teacher's job is if they were able to build the grading rubric, which is really what it was. Is I built a grading rubric inside so that the AI could do it each time. But like if they built a grading rubric, they just take a picture of everybody's thing, and then whenever the AI's finished, At least they could go home.
Yeah, frees up the teacher's time in addition to like personal things, for individualized instruction. I mean, most teachers will tell you like their biggest frustration is like how much time they have to spend every day just hunched over a desk grading papers as opposed to actually teaching and working with students who are struggling. So I think that could be a pretty exciting prospect, and one that I'm pretty thrilled about.
And it's easier job for the teacher to determine, well, was the AI's grading accurate than it is to actually grade it. That's why it's so much easier for experienced people to use AI, because it's like, well, yeah, it's so much easier just to take his answer and fix it than to start from nothing.
That is excellent perspective. Our guest has been Dr. Aditya Nagrath, a mathematician and best-selling author. Check out his book, Treating Mathematics Anxiety, Inclusive Strategies for Working with Students Exhibiting Mathematics Anxiety. Dr. Nagrath, before we let you go, and this has been a real pleasure, we got one last question for you. Okay. If with the snap of your fingers, you could make any change to the education system, what change would it be?
Well, it feels like we need to pay the teachers more. I don't know, like how. Like, so you snap a finger.
Well, no, this is. We don't have to figure out how to pay for stuff today. This is the snap the fingers game.
But like, if you think about it, right? I mean, this is a real challenge because, like, you know, more and more you're hearing. No, it just came out, right? There was some article I read saying 71% of teachers have to work 2 jobs or something like that. And it's like, well, yeah, but they're working 60 hours a week for 9 months out of the year. So like theoretically, this should pan out. You know what I mean? But yeah, that's the answer. Right?
It's excellent. And one that will not make you any enemies here at Big Ideas in Education. Nope. I haven't heard too many people on the other side of that. And I always tell guests, you know, in the pre-show, I don't think I shared this with you, but I was like, when in doubt, if you're not sure about the answer to the final question, pay the teachers more is always a crowd pleaser.
Is that a typical answer?
No, it's the one that I tell people to go with if they're struggling. You gave the number one most popular answer on the board, and it's one that I don't dispute. You know, frankly, if my feeling is, if you're willing to devote your life to the profession of teaching, college shouldn't cost you a dime, and you certainly shouldn't have to work a second job to do it. So, you know, love your insight there, and just love the insight that you gave throughout this interview. Really appreciate your time, sir.
I appreciate you guys. Thank you.
And thank you all for checking out Big Ideas in Education. We'll see you next time.
The views expressed on the preceding program have been those of the hosts and guests and do not necessarily reflect the views of Academica, its clients, staff, affiliates, or advertisers.